Okay, Bio30s, for this final lesson in topic 14.3, we're going to take a look at what's called dynamic equilibrium. We just looked at static equilibrium, which, as you will remember, it happens in the vestibule, all right, of the inner ear, in the utricle and saccules located there. We're going to be talking here about the three semicircular canals, all right, and their specific structures, the ampullae. So here we see this as the semicircular canal meets the vestibule, it opens up, all right, and so that's the ampulla. Inside the ampulla will contain a a crista containing the cupula and the hair cells. Okay, I don't know why Otoconia are here. They don't need to be. They're not part of this. You can just ignore that. Okay, now the semicircular canals. In fact, all of the inner ear is filled with a fluid called endolymph. And in fact, in hearing, as the stapes hits the oval window, it causes vibrations to go through the cochlea, through the endolymph, right? So through the fluid in the ear. The fluid here, all right, in the semicircular canals, also of course called endolymph, behaves in a different manner for dynamic equilibrium. So we have 1, 2, 3 semicircular canals in each ear, all oriented differently to detect movement in different planes. All right, so dynamic equilibrium involves balance while in motion and is maintained by the three crista, all right, that each rest within their respective ampullae. So within the ampulla, all right, within the three semicircular canals. So what's happened? Let's take a look at the lateral canal, although you don't need to know the names of the canals, all right? So we're just doing this very generally. But the lateral canal is exactly horizontal to the ground, okay? So let's say you start to spin, all right? You like we did as kids, right? You just, I'm gonna spin until I fall down, right? So what's happening, okay? As you spin, so if you're not spinning, there's no movement in the endolymph. But as you start spinning, the endolymph will start to move itself. All right? So, and it will cause the cupula to move as well. So you can see the cupula here is in a it's in its normal position, and here it's being pushed by the endolymph. Now the hair cells, okay, or the hairs from the hair cells extend into the cupula, and so they will be their position will change as well, and the hair cells will interpret this information, depolarize appropriately, and there you can see they're connected to these sensory neurons, which again will form the vestibular nerve. Okay, so again, as the endolymph moves, the cupula moves, the hair cells are are moved as well, causing depolarization in the cells, or the hairs are moved, causing depolarization in the cells, which will be picked up by the sensory neuron. That's just about as much as it is, right? This is about as much as we need to know for Bio30. So here's just another way of looking at it. You can really see the cupula here, which is changing position, and of course the hairs, which extend, will also change their position as movement occurs. Okay, so we have head rotating here, and it happens in a head rotation. You can, right, but really this is for a whole body movement. So it's the 6 semicircular canals, right? There's 6 of them, which are all sending information to the brain as you're moving around in the world. and the brain is interpreting all of this information, as well as information from the macula and saccule and visual perception and proprioception to keep your body upright in space, right? Or to keep your body doing what you want it to do. Okay, so as it says here, the movement of the endolymph. Remember, the fluid is called endolymph, and so these arrows represent that movement of the endolymph. Okay, causes the hair cells within the cupullae to change their normal position. Why? Because the hairs are changing normal position and cause action potential in the ampullary nerve. Okay, well, the vestibular nerve specifically. For this slide, there's not a lot here. Cupula, cupula. Okay, there's not a lot here for you. All right, so it's just one thing. 3 semicircular canals perceive motion in 3 planes, work together, provide input on the direction of the movement. And actually, it's the 6 semicircular canals that do that together. But again, we're not going to be looking at this any further. So what do you need to know, right? You need to know the names of the structures, and you need to know how hair cells are triggered. That's really what you need to know for both static and dynamic equilibrium. All right, I hope that helps. Thanks a lot for your participation, and good luck with this lesson, and we'll see you in the next lessons.